looking at IP85. This is number 7. This is a classic sort of proportional reasoning scenario where you use indirect measure to tell how tall something is based on like shadow lengths. So we got a person who's 5'3" tall. They're going to cast a 6-foot shadow. At the same time of day, a lamppost casts an 18-foot shadow. What is the height of the lamppost? Draw triangles to set up a proportion and solve. Okay, so let's say we got a person. It's my amazing drawing. They are 5'3" and they have a shadow going this direction. We also have a lamppost. It's my amazing lamppost direction. It's supposed to be lit up. And it is casting a shadow as well. And then, so that actually is the beginnings of a right triangle. The reason it's a right triangle is it's really those sun's rays coming down to make that shadow. Well, the sun's rays always come down parallel. So that means that this angle right here and this angle right here are going to be the same. And then also because the person is standing up straight, they got a right angle. The lamppost is assumed to be planted or installed straight up and down, so that means there's a right angle. So we got similar triangles versus angle similarity. Let me get some of these lengths on here. We have a person who's 5'3". If you haven't seen this notation before, this is the notation for feet, is with a single apostrophe and a double apostrophe is inches, so that's 5'3". They got a 6-foot shadow. And then we got a lamppost casting an 18-foot shadow, so 18 feet here. We're trying to figure out what this is. Okay, so these drawings work. They are right triangles. They are similar, but there's a couple issues with them. Sometimes the drawing itself, like having an actual person or trying to draw a lamppost, can make it a little bit harder to digest. So I often will recommend just drawing really plain right triangles. That's the person with their shadow and the sun's ray and the ground. Here is the lamppost. So right, these angles are the same. Similar triangles via angle similarity. The other issue that we have is, look, we got feet here, but then we have feet and inches. We really want to get the units to all be the same. And it tends to be easier to make them all the same smaller unit so you don't have any fractions or decimals. So I want to make these all into inches. The feet one are pretty easy. Every foot has 12 inches. So I'm going to do 18 times 12, right? Every foot has 12 inches, so 18 groups of 12, 18 times 12. This becomes 216. So this is going to become 216 inches. The 6 feet, same idea. Every foot has 12 inches, so I'm going to do 6 times 12. That's going to get me 72. This becomes 72 inches. Now this one's a little bit more complicated. I need 5 groups of 12 plus 3 more inches. So I'll do 5 times 12, and then I'll add 3 to that. That brings me to a total of 63 inches. And then my unknown here will be x. All right, from here I'm going to go ahead and set up and solve a proportion. There are multiple correct proportions to do. On these types of problems, I often will do corresponding sides. So, you know, this height here is going to correspond to that height here. And then we'll have, you know, the shadow length corresponding to that shadow length. So I'm going to do 63 to x. It'll look like this, 63 to x. And because they're similar, that's going to be the same ratio as if I do 72 to 216. So 72 to 216. I can set those two equal because of the similarity. And now I'm going to solve with cross products. The numbers are going to get fairly large, but that's okay. I'm going to have a calculator do the heavy lifting for me. X times 72, that's my first cross. That'll become 72x. I'm going to set that equal to the second one, which is 63 times 216. Oh yeah, that is a very large number, 13,608. But if you look, my next step in the math is to divide both sides by 72. So I can just take my previous answer, right, divided by 72. It goes in there evenly, 189. So that is the height of the lamppost. But remember, we converted all of these units back into inches. You really wouldn't say that a lamppost is 189 inches tall. We would put it back in feet. So the lamppost is 189 inches. But I'm going to divide that by 12 and figure out how many feet are in there. Oh, unfortunately, it doesn't go in there evenly. And this can be a little bit annoying. You don't really do 0.75 of a foot. You want to convert it back into inches. So look, I got 15 whole feet. The lamppost is 5 feet. Well, how many inches is that? We got a couple different ways to do it. We got this 0.75. So I can do 0.75 of my 12 inches. All right, it's 3/4 of it, which is 9. Another way to do it, I'm trying to think, would be, to do, convert that to a fraction, the 0.75, that's 3/4, and to do 3/4 of my 12 inches, same thing, it's going to be 9. The way I like to do it is just take that decimal, and it's that much of a foot. It's that much of 12 inches, 0.75 times 12, 15.75. Oh, another way you can do it is like figure out how many full numbers of 15 are in there. So let's see, 15 times 12, that gets me to 180. I started at 189. So because it divided in there and was 15.75, I figure out how many groups of 12 is 15. So 15 times 12, that takes me to 180. I need 9 more. So either of those work. But I would give my final answer in this structure, that the lamppost is 5 foot 9 inches tall. Hope that's helpful. Message me anytime with questions. I'll see you in class.